Okay guys, what we're going to look at now are inequalities and graphs. So, if we have an axis like this, okay, and on that axis we have some graphs. So let's say that we have a nice parabola like this one, and we have a nice straight line, which I'm going to draw properly, like this. Okay, now, whoops. What we're going to do in this case is firstly we're going to label these points here. Okay, so we're going to say that this point here is going to be a value of, let's say, 5, and this point here is going to be a value of -2. All right. Now, when we look at inequalities graphically, we will usually get some sort of situation at the beginning. So the question will say something like f of x is greater than gx. Okay, and let's call, in this case, fx can be red and gx can be green. All right, so if we're looking at fx is greater than gx, so the function f is greater than the function g, what we want to know is where the red line is greater than the green line. Okay, and in reality that just means that the red line is higher than the green line. Okay, so the y value of the red line is above the y value of the green line. So we need to look on our graph and find where that is. Now, in this case, you should be able to see that at -2 and at 5, the functions are equal. Okay, so at -2 and at 5, those functions have the same value. Okay, so we know that this situation where the red function is higher than the green function, the red line is above the green line, will happen either in between -2 and 5 or outside. Okay, and you can see in this case that where I am highlighting here now, our red line is higher than the green line, and only where I've highlighted. Okay, on the outside, the green line continues up at a higher rate than what the red line does. Okay, so in between -2 and 5, the red line is above the green line. So therefore we know that our answer to this problem is that -2 is less than x, which is less than 5. Okay, and we always circle this on our graph and show it. Okay, I should have done this first, because this shows that we are looking at an x range from -2 to 5. Okay, that's as hard as it gets. It's quite simple. We're going to do a couple more examples just to make sure you guys get it. So let's draw another one. I'll move this over, it can line up with the other guy. Okay. And in this case, we will do a parabola like this, and a parabola like this. Okay, we will say that this value here is going to be -1, and this value here can be 3.5. Or let's just make it 4. Doesn't really matter. Okay, this is just as an example. And this time, I want to know, we'll label them again, F and G, and I want to know again where fx is greater than or equal to gx. Okay, so again, let's color code it first. So let's look at the colors that we have here. F was red, so we want to know where the red line is greater than or equal to the green line. Okay, and again, we need to then look at our graph. Is it inside? Is it in between -1 and 4? Or is it outside? Is it below -1 and above -4? Well, you can see in this case that it's below -1 and it's above 4. Okay, so again, we're going to, on the axes, we will circle these numbers and we'll show that it's actually outside this range. Okay. Now, in this case, it was greater than or equal to, so that also means that we need to color the circles in, same as before. Okay, so we have x is less than or equal to -1, or x is greater than or equal to 4. And that's our solution. Okay, the really important thing is with inequalities that are not linear, always, I'm going to write always in capital letters, always draw a sketch. Okay, this is part of your calculations and we actually give you points for this, including next year in year 4. Okay, so always draw a sketch with inequalities that are not linear. With linear ones, it's okay because we only get one solution, but with inequalities that aren't linear, we need to actually look at the graph to see what we're getting as our answer. Okay,